Richmond, Kentucky is home to one of over 20 EnerSys manufacturing facilities worldwide. Built in 1976, the Richmond plant manufactures a complete line of industrial batteries for motive power applications, as well as reserve power and railroad battery needs. This 350,000 square foot facility employs over 300 people and currently produces over 200 batteries containing 4,800 cells each day. It's also headquarters for our National Parts and Service Center, which provides same-day shipment of over 250,000 parts for batteries and chargers. The 90,000 square foot distribution center contains over 2,800 pallet spaces. The Richmond plant was the first American industrial battery plant to enjoy registration by the International Organization for Standardization, receiving ISO 9002 registration in December of 1993. Today, all EnerSys manufacturing, engineering, corporate, and field service locations have attained ISO 9001 certification, while Richmond continues to lead the way, being the first plant in the Americas to successfully transition to the updated ISO 9001-2015 version of the standard. As we tour this state-of-the-art facility, you'll see firsthand the quality-driven process and attention to detail that makes the Douglas battery product line one of the best flat-plate batteries on the market. You'll also appreciate how the strict adherence to statistical process control procedures ensures a consistently high-quality product. The battery manufacturing process begins with purchased and secondary lead being converted to lead oxide. At the Richmond site, approximately 60 to 70 million pounds of lead are used each year to manufacture batteries. 90% of the lead used is received from recycling centers, and only 10% is virgin lead. All purchased lead is tested for purity. Douglas Battery adheres to a strict quality assurance program where all purchased lead must meet these standards. The characteristics required for specific battery performance determine what alloy is added to the lead for optimum benefit. Lead alloys are differentiated by color code and stored for use in plate and intercell connector manufacturing. Various other lead parts for the batteries, such as post assemblies, plate straps, and intercell connectors, are made in another area of the plant. Some parts for specific batteries are molded with copper inserts for better conductivity, less voltage drop, and better performance. It's a more expensive process, but helps assure the superior quality of Douglas batteries. Lead ingots, called hogs, are converted into lead oxide in a closed Barton pot process, where the lead is heated to 800 degrees Fahrenheit, causing some remaining contaminants to float to the top and be removed. Lead is then channeled from the bottom to be atomized by revolving blades and converted into lead oxide powder. This powder will be used in the paste to create both negative and positive plates. Particle size, weight, and free lead content are checked for consistency and recorded for statistical process controls. To maximize the effective area of the plate's surface and thereby increase battery capacity, the most common approach has been to use finely powdered lead oxides in a paste. However, pastes alone are not good electrical conductors, so a lead structure or grid is added to conduct current to all parts of the material. Physical dimensions and weight are the most critical measure for ensuring good negative and positive grid casting. Our quality assurance program checks for optimal consistency. Each negative and positive grid casting has a mold number for easy traceability in accordance with the Douglas Battery Statistical Process Control System. The Richmond plant uses automatic paste mixers to measure out the proper amount of lead oxide from the oxide mill and mix it with water, sulfuric acid, and other proprietary additives for improved performance. Paste mix components are tightly and accurately controlled during mixing, and the paste takes on elastic moldable characteristics in order to adhere to the negative and positive plate grids. The paste must meet stringent quality assurance standards for density, consistency, and temperature. The pasting machine forces the paste into the negative and positive grids. The plates are checked for equal filling of the grid, thickness, and weight, and then sent through a flash drying process to allow for easy stacking and handling. The negative plates are stacked on pallets and placed in a temperature and humidity-controlled room for curing. The positive plates are hung in racks and placed in ovens for optimal conversion of the active material during the curing process, creating the industry's most conductive positive grid structure. This results in less resistance to flow of current and more power produced within the grid for increased performance at all levels, especially at high current discharges. The positive plates are moved to the cell assembly area, where each plate is individually wrapped with a horizontal and vertical material and held in place with a core-seal mesh before being inserted into the sleeves. One of the reasons for early battery failure has been the misalignment or omission of the separators that prevent contact between the negative and positive plates. If they are hand-inserted, error is a possibility. Douglas Battery has overcome this failure mode by making separator sleeves that fit around each positive plate, so visual quality checks are sufficient to assure they are in place. In addition, these sleeves insulate the edges of the plates from edge shorts. The sleeves are welded ultrasonically and cut to the proper length. A test verifies the weld is stronger than the base material. The positive and negative plates are stacked together to form an element. After the element is assembled, all the negative plate lugs are welded together and connected to the negative post in a process called lead burning. Then all the positive plates are connected together at the positive post of the cell. To ensure quality and consistency, burners must meet proficiency standards and be certified. The completed element assembly is then put into the jar and fitted with a cover that has a color-coded positive post inserted bushing. The colored bushing indicates the type of cell it is: red for Douglas Legacy, green for Douglas Low Maintenance, and gray for Douglas Arctic. Douglas Battery uses a heat seal method to permanently join the cover to the jar. The seal is as strong as the original material, which prevents electrolyte leakage, corrosion buildup, and power loss due to electrolyte dilution. They are identified by type, date built, shift, and the heat seal machine each was built on to assure traceability. Each cell is individually air pressure tested underwater at 5 psi to make sure there are no leaks in the completed cell. The completed cells are placed into steel trays and fitted with permanent connectors. The batteries are now ready to be moved to the formation room, where they will be filled with a dilute sulfuric acid. Formation is the process that makes the active material active. EnerSys forms batteries with a unique advanced clean energy closed-loop formation system we call ACE. This unmatched and evolving technology enables us to form and manufacture a much more consistent product, and to do it more efficiently than other formation processes. And just as importantly, in an environmentally and worker-friendly atmosphere. While the ACE technology is largely proprietary, it is the benchmark for lead-acid battery production. It encompasses a series of self-contained, computer-controlled modules in which batteries are formed. Rather than forming individual cells, the ACE system forms an entire battery at once. Forming the cells as a complete battery ensures each cell in the battery meets the exact requirements for that battery type. This precise control assures every cell is matched within a battery, eliminating imbalances and ensuring the highest quality possible. In addition, the system's flexibility enables Douglas Battery to form batteries of all types and sizes in a single production run. The ACE multi-step electrochemical forming process allows exacting control of electrolyte-specific gravity, temperature, and formation current. This control enables us to form the best active material possible, which results in more energy per cubic inch than any other battery in the industry. The entire ACE system at Richmond is a breakthrough for the environment. Emissions are virtually eliminated because it's a self-contained system. There's very little waste and no runoff to treat, recycle, or dispose. Also, the ACE technology provides tight control of the acid used during formation. Each module is filled with the exact amount of acid needed for each batch being formed. There is no excess or wasted acid to deal with. For employees, the ACE system has many benefits. First, it scrubs the air and removes much of the sulfur odors generated by formation. Second, potentially hazardous hydrogen and oxygen gases are eliminated from the formation room. Finally, our employees can control most of the ACE cycle from a remote location. After formation, each battery is placed on a high-rate discharge test to ensure the integrity of all intercell posts and assembly connections, ensuring the battery will be able to perform in every possible application. During final assembly, dozens of inspections are made to ensure that strict physical and electrical standards have been maintained. Battery decals are added, and every battery is weighed. The actual weight is stamped on the end of the tray in accordance with various industry standards. The EnerSys manufacturing plant in Richmond, Kentucky, is a state-of-the-art facility creating world-class quality batteries in a safe and environmentally friendly atmosphere. All acid mixing, handling, and storage is done outside in large fiberglass tanks. The acid is monitored to make sure the acid quality meets the standards required for battery production, while strict safety protocols are followed to avoid any injury to employees or damage to the environment. Any battery-making process produces lead dust, but Douglas Battery uses a negative pressure system in the plant whereby air is collected at all the dust-generating locations and brought out to a baghouse operation, where the dust is taken out of the air and collected for recycling. This is to make sure that no employee inhales lead or is exposed to a lead poisoning hazard, and to ensure that we are not releasing any lead into the air or ground surrounding the Richmond site. Finally, our greatest asset is our people. All employees of the Richmond facility are part of our statistical process control system, whereby every individual is responsible for the quality of their operation. Each part must meet quality assurance specifications before progressing to the next step, while the Quality Control Department conducts spot tests and administers inspections throughout the plant. At EnerSys, we believe the enthusiasm and ongoing feedback of every employee can only improve the quality of our already superior products. And in Richmond, Kentucky, our technologically advanced manufacturing, exceptional care and attention to the environment, and enormous pride make Douglas Motive Power batteries the best.